In example 3, 4, and 5, we're going to look at some specific examples of cyclic groups and see if we can come up with some kind of result that maybe we can generalize and learn something about the structure of cyclic groups in general. So keep that in mind as you are working through these examples. Example 3, we are looking at the additive group Z6, so the integer is mod 6. And we're going to look at all the cyclic group generated by all the cyclic subgroups generated by each of the elements in Z6. And if you haven't done so already, I encourage you to stop the video and work through this example on your own before you come back and watch me work through it. Okay, let's have a look at this together. So the first thing they want us to do is to just write down all these cyclic subgroups. So let's write them down. We're looking at Z6, and that is 0, 1, 2, 3, 4, 5. Now, that is a cyclic group generated by 1 under addition. So this is a cyclic group. And let's look at all its elements one by one. So if we're just taking 0, there's not much in there, that's the identity, it's just the identity by itself. 1, we already wrote down what we get when we generate all the powers of 1, so 1, 1 plus 1, 1 plus 1 plus 1, and so on. That is Z6 itself. What do we get when we take 2 as a generator? Well, we have 2. We get 2 plus 2, that's 4. And then 2 plus 2 plus 4, that's 6, which is 0. So that is really all I'm getting. Then we are starting over. What do we get when we start with 3? Well, we're going to get 0, and we're going to get 3, and then 3 plus 3, that's 6, that's 0 again, mod 6. What about 4? We're going to get 0, just going to write that down. Then we get 4. And then what do we get when we take 4 plus 4? 4 plus 4, that is 8. 8 mod 6 is 2. And is that it? If we take 2 plus 4, that's 6. Okay, yeah, that's it. That's 0 again, mod 6. So we are just getting 0, 2, and 4. What do we get when we start with 5? We have 0. We have 5. Then we have 5 plus 5. That's 10. Mod 6 is 4. Okay. Then 4 plus 5 is 9. Mod 6 is 3. 3 plus 5 is 8. Mod 6 is 2. 2 plus 5 is 7. Mod 6 is 1. 1 plus 5 is 6. Mod 6 is 0. So then I'd start over. Okay, so this is what we have. We accomplished our first goal. We wrote down all the subgroups generated by 0, 1, 2, 3, 4, and 5. And now let's have a look. What do you notice? What questions come up? Well, one thing that I'm noticing that we generated all of Z6 a couple of times. So we got our complete group twice, generated by 1 and generated by 5. So our group has 2 generators. That's one thing that we could write down. So 1, the group generated by 1 and the group generated by 5 is all of Z6. One thing that we noticed. Do you notice anything else? We also have 0, 2, 4 show up twice. Once generated by 2 and once generated by 4. So we have the group generated by 2 is equal to the group generated by 4. We don't get everything, but we get the same subgroup, 0, 2, and 4. And so that brings up the question, is that coincidence or is that something that might be generalizable? And at this point, you may want to stop, do example 4, and look at what's happening in example 4, and then we can generalize some of the things that we are seeing here in both of those examples together. So the next video will be about example 3 and example 4 together and seeing if we can come up with something to